All right, here we go. Lesson 1-6, if my pen will work. We are going to explore angles. Doesn't that sound exciting and dramatic? Whoops, I'm going to put an I instead of an E. How about exploring angles? Well, it's all in how you go about it. If you think it's exciting, maybe it will be. All right, so a couple of things. First of all, let's look at what an angle looks like. An angle has certain parts to it. An angle is made up of, technically, two rays. Isn't that a ray? And isn't that a ray? Two opposing rays make up an angle. And so, you have to open the notebook and get a pen and copy down what I write. This is not a volunteer class. What's this little point right here called? It's not a dot.
Right angle. No, just kidding.
No, just the dot itself. Not a point. Oh, it is the vertex. Make sure that you know now that that's the vertex. And these right here, this would be the side. There are two sides to an angle. Here is your true angle definition. This means if it's a definition, you are making an additional flashcard and adding it to that stack of 90 some odd flashcards. And you are studying this. So an angle is constructed from two rays. If I ask you what an angle is, you will say that it is constructed from two rays. Now let's say that we have opposite rays. There is a difference between just two rays and what opposite rays look like. If this is a ray like this, what's an opposite ray to this? What would be an opposite ray? Wouldn't it go in the exact opposite direction? If I said go north and you're going north, I said no, turn around, go in the opposite direction. Wouldn't you go south? So opposite rays look like this. What does that form? A straight line. What is the angle measure of a straight line? 180 degrees. So opposite rays are 180 degrees. They form what we call a straight angle. It still forms an angle because 180 degrees is still considered an angle. But we call it a straight angle. And then you might also say that the rays would be collinear. What does that mean? They're on the same line, right? They have the same endpoint. That vertex of those opposite rays is the same endpoint. All right. Let's look at the actual other parts of a ray, because you're going to be asked to note this. So let's draw another angle. Okay, so there's that lovely angle again. Now, would you not agree that, let's look at the angle itself, the sides of that angle and the vertex as a fence. Wouldn't this be one part of the fence? The part on the outside? And wouldn't this be a second part of the fence? The part on the inside. So if a problem refers to the interior or the exterior of an angle, this is what they're referring to. So the green part, good morning, is the exterior. Thank you. Cece, a delivery for you, my dear. There we go. All right, so the green part is your exterior. The yellowy orange part is your interior. And then the third part would be what? What's the third part? The angle itself. So you might want to note here that an angle cuts a plane into 3 different parts. And so we've used one of the words that we've talked about before. An angle is going to cut that plane into 3 distinct parts. So make sure that you know those distinct parts so that when they're described to you, you understand and you can draw a picture. Because they're not always going to draw you a picture of what's happening. They're going to describe to you what is happening. All right, we have 2 postulates and then a few other definitions, and we're done as far as this goes, and we're going to work on some problems together. Are you ready? So this means it's like flashcard number 3. Postulate 1-3. Write it down. Don't put the pencil down. This is called the protractor. Oops, I just spelled it wrong. How about this? I'm not quite awake yet this morning. We'll just start over again. You gotta love that. Protractor. Huh? No, that's spelled right. Protractor. It's not an ER. So this is your protractor postulate. It's kind of like the ruler postulate. Remember we talked about the ruler postulate the other day? Well, this is your protractor postulate because what measures an angle? A protractor. What measures a line? A ruler. That's why they're called what they are. So a protractor postulate just basically says, given, what notation does this mean? What's just one arrow on the line mean? A ray. So given ray AB, isn't that part of an angle? What's the vertex of the angle? A or B? A, isn't that the endpoint of the ray? Wouldn't that be the vertex of the angle? Okay. So given ray AB and a number, let's just call it R, between 0 degrees and 180 degrees, isn't that what a protractor measures things at? Protractor only goes, well, the inside scale goes from 0 to 180. If you want to go past 180, you have to add on to that. There is exactly one ray with endpoint A extending on either side of ray AB such that the measure of the angle formed is R. Oops. And let's talk about what that means while you're finishing writing that. Pardon? What was that? Yes, it is IS. Shocking but true. Let's say that this angle right here we had the points A and B. Wouldn't that represent right AB? All this is saying is that R is the measure of the angle. If I said that I wanted, a 30-degree angle, and obviously I haven't drawn a 30-degree angle here, but wouldn't I put my protractor right here, line it up with a 0, which is hard to see in the glare, but line it up with a 0. If I were to draw a 30-degree angle, wouldn't there be only one place that I could draw a ray going from A through the protractor at 30 degrees? There's only one place I could draw it. Would you agree? For it to be a 30-degree angle. So in this case, the angle happens to go up to here, which is about what? A little shy of 70 degrees, right? That's all they're saying is from here to here, that represents R. And in this case, let's just say it's 68 degrees. Just measuring with a ruler, or with a protractor. And there's only one measure it could be. That's really all the postulate is saying. Ready for the second postulate? You're going to think it's familiar too. Esteban? Do you need this? Okay. Will you send that back? Okay. All right. Just straight back. All right. The second postulate is called your angle addition postulate. Have you heard that before? Yes. How did you hear that before? What does it sound similar to? Come on, what does it sound similar to? Starts with an S. Segment addition postulate. Don't you think they're going to say the same thing? Yeah. Pretty much. All right, so 1-4 is called the angle addition postulate. And all it says is if R, and R is capital, so it represents a point, is in the interior of angle, and here's your notation for an angle. It looks like a little tiny angle, but we put a curve through it so that you don't think it looks like a less than sign. So this is some new notation for you. I would start making your angles look like that, so you don't have to write the word angle. You can just draw this cute little angle. PQS. Then the measure, and this is another one. And if I want to say the measure of angle PQR, and we're going to draw a picture, I put a little M in front of the angle symbol, and you might want to write yourself a note. It means the measure of angle PQR. So in a minute, we're going to draw an angle of PQS. We're going to put R in the interior of that angle, and we're going to create another angle called PQR. So don't worry about all these letters and stuff. We're going to draw a picture and talk about this, and it'll make sense. So then the measure of angle PQR plus the measure of angle RQS is equal to the measure of angle PQS. And then you can also say this in the reverse. If you were told that the measure of these two angles add up to the measure of this is going to end up being the whole bigger angle, then you can conclude that R is in the interior. So again, here's one that we could read backwards. So let's draw a picture of what it says. So let's draw an angle. We're going to draw the big angle. It doesn't matter how big or what you make it look like. It says R is in the interior of angle PQS. Where do you think the vertex of PQS is? Is it P, Q, or S? Q. The middle angles are always named by 3 letters. There's another way to name angles, which we'll talk about in a minute, but typically you name angles with 3 letters and no more and no less. Whatever the middle letter is, that's the vertex. So I know that Q goes here. It really doesn't matter whether P is here or S is here. It doesn't matter which ones go where. But Q had better be in the middle. That's your vertex. And you always know the middle one's the vertex. I could name this angle either PQS or SQP. Either one is acceptable. Now, if I had named this angle, if there was a little 1 there, you could also name this angle. So here's the names of the angle. Angle PQS. There's one name. Angle SQP. So you could reverse the outer points. Or we could actually name it angle 1. If there's a little number in there, 1 through 9, or whatever, you could even go up to, I don't know, you can get 2-digit numbers, depending on how many angles we have in a picture. But whatever this number is here, we can name the angle that number too. So there's your 3 ways to name angles. You're going to be asked that on your homework. Now, this postulate happens to say that R is in the interior. You can put R anywhere in here. So put point R anywhere in the interior. Isn't that in the interior of that angle? Couldn't I attach R to the vertex Q and cut this angle into 2 pieces? 2 different angles? Can't I add another ray, QR, that divides that angle? And so now, don't I have 2 additional angles? Isn't this, how would you name this angle right here? This one right here, from here to here. PQR or RQP. Could I name it angle 1? No, because angle 1 refers to the whole big angle. Okay? So this is what they're saying here, that here's angle PQR from PQR. There's angle PQR. If I add to that this other angle here, this one here, how would you name that angle? RQS. So I'm going to put a little angle marker here. RQS. What does it equal? What's the whole, don't they add up to be that whole big angle? PQS. So the 2 smaller angles add up to the whole bigger angle. Is that any different than the 2 smaller pieces on a segment adding up to the whole bigger piece of the segment? Do you anticipate that they're going to give you similar problems to the segment addition problems? So they're going to say that the measure of this angle here is like 5x plus 2. And the measure of this angle here is 2x plus 3. And the whole measure of the angle is 15x. I'm just throwing out numbers. Wouldn't you add this to this and set it equal to 15x? Okay, there you go. So you're going to have a lot of those similar types of problems, but it's related to angles. It's no different than what we've been doing, but it's angles. So look at it the same way. All right, are you ready? Oh wait, I have to give you a couple more other definitions. So we are going to talk about congruent angles. What do you think congruent angles are? Equal angles. So what's a congruent angle to a 40-degree angle? A 40-degree angle. Do we need to write that down? No. Okay, so here are your other angle measures that you could have. You could have an acute angle, right? Maybe I should use a ruler for this. You could have an obtuse angle, and you could have a right angle. What is the definition of an acute angle? Okay, acute angles, very good, is less than 90 degrees. Its measure really goes from 0, well, greater than 0, to 90 degrees, right? A 0-degree angle really isn't an angle, isn't it just a ray? Wouldn't you agree with that? It's just a ray. All right, an obtuse angle, and you can think of acute, what's a cute little thing? Aren't little tiny things, don't we say they're so cute? Things that are, I have never been accused of being cute. I'm 5'10", I have size 10 shoe, okay? I have never been called cute in my life, okay? So I am not cute, right? I'd actually call myself obtuse. Obtuse is generally related to the word obese, right? I wouldn't say I'm necessarily obese, but you know, you get the picture, right? Obtuse, obese, big, right? So obtuse is what? Okay, so an obtuse angle would be greater than 90 degrees, but it has to be less than 180 degrees. An obtuse angle is not equal to 90 degrees, and it is not equal to 180, but it is in between the two. So 179.9 degrees is obtuse, but 180 degrees is not. What is a 180 degree angle called? Straight angle. What's a 90 degree angle called? So this is exactly 90 degrees. So an acute angle can go all the way up to 89.9 degrees, but the minute it hits 90 degrees, it's no longer acute, it's right. Do you see the difference? Okay, any questions on that? Riley, where's Riley? There you are. You have a ticket out of here. All right, now we are going to work some problems, and we're going to do them on whiteboards. So unfortunately, I'm going to stop my video, and so these problems are actually going to come from your workbook, but we're going to work on them together.